In these notes, we are going to discuss and take a look at all the different things that you're going to have to do requiring functions and relations. There are several different examples. I will do some of the examples with you, and the ones that I do not do with you through this video, you will be responsible for completing on your own using the examples that I have provided. First and foremost, let's define and take a look at what characteristics a function has versus a relation. A function consists of a set called the domain, which are your inputs. And an easy way to remember this, input starts with in, domain ends with the words in. Okay? And it consists of a set called the range, which contains all the numbers called the outputs. So when a number goes in, that is known as your domain, and the number that comes out is known as the range. Okay? Functions also consist of a pairing of inputs with outputs so that every input is paired with exactly one output. So that makes that the x value does not repeat. If your x value does repeat, then you do not have a function. Right? So it's very important that you look at those x values to help you determine when something is a function or not. In a relation, that is when an input has more than one output. So we call that a non-function, for lack of a better word. Okay, so if it's not a function, then it's known as a relation. A relation is any set of ordered pairs. Okay, so basically everything can be listed as a relation, but some relations are classified further as functions. Right? Instead of a non-function, you might want to put underneath the better word of relation, because that's exactly what it is. If it's not a function, then it's only a relation. All right, for example 1, you're looking at different versions of or different representations of functions, and we want to determine from those if it truly is a function. And if you notice the directions after that, it says if it is a function to give the domain and the range for it. So in number 1, we have the mapping. Right, and remember your section on the left is the input, so if you might want to label it as in, and then your section on the right is your output, so that's your out. Right, so we want to take a look at these, and we want to pay attention to the inputs, because if any of those x values get used more than one time, then it is not a function. You notice that the 1 goes to the 2 goes to the 2, and the 3 goes to the 4. The 1, 2, and 3 only have one arrow coming off of them. So because none of the x values repeated, in example number 1, that is a function. Okay, and because it is a function, we were asked to identify the domain and range. Right, so the domain would be all of your x values or your inputs. So that would be the numbers 1, 2, and 3. Your range values would be all of the outputs, but do not repeat numbers. You only want to list them one time. So because 2 got used twice, we're going to write it only once, and then the number 4 was also used. So even though there are less numbers in the range column, one of them got used repeatedly. Right, if you go to number 2, you'll notice that they gave you a different representation. It's an ordered pair this time, but you're still focusing on those x values. So if you look at the x values that I'm underlining, you ask yourself, do any of my x numbers repeat? And you can tell that the first ones do repeat. So in number 2, this is not a function. And because it's not a function, we do not need to identify domain and range. Okay, so we'll do more with that in class over the next few days in terms of identifying functions versus not functions, but it really does rely on that x value. Okay, when you have graphs, the x values are not as used as often, as there's a special test, and it's called the vertical line test. Remember, vertical lines go up and down. So basically what you're looking to see is, can you draw a vertical line through any part of the graph and hit the graph in more than one spot? Okay, and that's what this fill in the blank is about. That a relation represented by a graph is a function provided that any vertical line, doesn't matter where it is, okay, passes through, and you need to add a word here in between the word through and more, it should say no more than one point on the graph, because if it goes through more than one point on the graph, then obviously you do not have a function. All right, so I am going to do numbers 3 and 6 with you on these notes, and then you can come to class with 4 and 5 answered, and we'll see how you do. Right, for number 3, right, if I draw any vertical line anywhere in this picture, you can tell that I'm only going to hit that V-shaped graph one spot on each one of those vertical lines. So because it only hit one time, right, then number 3's graph is a function. Okay. If you go to number 6, and if I draw vertical lines, you're going to notice that on these vertical lines, I'm actually hitting the graph in 2 spots, which means it fails the vertical line test. So you either pass it or you fail it. If it fails the vertical line test, then you say, no, it is not a function. Right? So number 3 is a function because it passes. It only hit once. Number 6 is not a function because it fails the test. So you try numbers 4 and 5, and we'll see in class what you come up with based on your ability to do the test. Okay. If you go to the back side of the sheet, right, you're looking at function notation. Just like there's scientific notation and all these other types of ways to write numbers, function notation is just a fancy way to write functions. Right? You're going to see it written as f parentheses x, right? And that replaces the letter y. And it's read the value of f at x, or we simply just say f of x. And that's the easiest and quickest way to say it. So whenever you see f of x, g of x, k of x, L of x, it doesn't matter what letter of x, right? Then that is replacing the value of y in your equation. It does not mean multiply, so make sure that you do not try to multiply things. Okay, and f of x is called the function notation. It's just a fancier way of showing you that you have a function. Right, so for these next few examples, you're going to notice that function notation is being used, and we're going to embed some values that they give us and evaluate these functions. So if you look at number 7, they gave us the function f of x equals 2x minus 3, and they want us to evaluate it when x equals negative 2. Right, so they're giving us the x value. So basically what you need to do is take out the x's in each one of these problems, and you need to replace it with the number negative 2. Right, so here's what it would look like. Instead of saying f of x, you're now going to say f of negative 2 equals, and instead of saying 2x minus 3, you're going to say 2 times negative 2 minus 3. And we're going to use our order of operations skills to evaluate the right-hand side. Okay, so it's still going to stay f of negative 2 on the left, but we're not going to do anything with that until we get to the end. You're going to multiply first, so 2 times negative 2 is negative 4, and then you're going to subtract 3 more. Negative 4 minus 3 is negative 7. So we write this as saying f of negative 2 equals negative 7. What that means is that the number negative 2, when you put it into this function, negative 7 comes out. So your domain is your negative 2, that's also known as your input, and the negative 7 is your range, because that's your output. Okay, now you don't have to identify domain and range for each one, but that's how this works. We can do a lot more with those two numbers, and we'll talk more about them in class as we go along and through some of these other examples. All right, so I'm going to go ahead and jump over and do number 10, and then you're going to be responsible for 8 and 9 from this section. So in number 10, we have f of x equals 10x plus 3, but they want us to find x equals negative 1. Right, so we are going to really find f of negative 1 equals 10 times negative 1 plus 3. Okay, so do all the math on the right-hand side. 10 times negative 1 is negative 10 plus 3, so that makes negative 7. So f of negative 1 equals negative 7. Okay, so use the space on the right to do all of your work, but then come over here to the left, and under each problem that you do, actually put the answer. So for number 7, we'll write f of negative 2 equals negative 7. That was the answer that we found. And for number 10, we had f of negative 1 equals negative 7. Okay, so you do numbers 8 and 9, and let's see what you come up with from those. For example 4, we're going to take a look very quickly at graphing some functions based on the problems that you already have. I will do number 11 with you, and then I want you to try number 12 on your own. When we're graphing a function, because it's an equation, we want to connect the dots, right? But you can't just randomly put dots. So this is where you have to go back to your pre-algebra days, and we're going to have to make a table, right? And you should remember taking and doing these tables where you figure out your inputs and your outputs based on numbers you pick. So in the middle column is where you put everything that's after the equal sign. So in this case, I would put negative 1/2 x plus 3. Okay, and I get to pick what x values I want to use. Always pick easy numbers to use. Because this is 1/2, I want to use numbers that are going to be able to be split in half easily. If you don't have a fraction, you can pick numbers such as negative 1, 1, 0, and so forth. Try to pick a negative, a 0, and a positive number so that you can get a good picture of the graph. So I'm going to use negative 2, 0, and positive 2. Okay, and what you do is you take the x out and you insert the number that you just picked. So I've got negative 1/2 times negative 2 plus 3. Okay, half of 2 is 1. Negative times negative is positive, so that's positive 1 plus 3, so that gives me 4. Okay, then I'm going to put 0 in. Negative 1/2 of 0 plus 3. Well, half of 0 is still 0. 0 plus 3 is going to give me 3. Then I want to use negative 1/2 of 2 plus 3. Half of 2 is 1, but there's a negative, so that's negative 1 plus 3, which gives me a positive 2. So now I've created 3 ordered pairs that I can plot. So I'm going to plot on my graph negative 2, 4, 0, 3, and 2, 2. Right? And those are going to make my 3 points to connect. So negative 2, 4 would be right here, 0, 3, and 2, 2. Because it was an equation, we want to connect it with a straight line, and lines keep going forever, so we put arrows at the end of them. Right? So you try your hand at number 12. Don't get too bogged down with it, though, because we're going to do a lot more with graphing in the upcoming weeks and chapters. Right? So just see what you can do with it, and we'll talk about number 12 in class based on what you come up with. Right? If you go to the next sheet, actually, before we go to the next sheet, use some white space at the bottom. Before we go too much farther, I want to insert this little tidbit of information. There are 4 basic function types that you are going to be responsible for learning in the course of Algebra 1, right? And we will spend a good chunk of time on the first one, and then after that, the time will change and be less and less. Some of them you don't even get to until in Algebra 2. We touch on them a little bit in here in terms of naming them, but after that you actually graph them more in depth in Algebra 2. So the first type that we are going to spend almost the first semester dealing with is a linear function. And just like the word says, if you look right in there, you see the word line. So linear functions are your straight lines. And that's how you can remember what they're called. You will have to recognize by picture which ones are linear. Okay, but if it makes a straight line with no curves, bends, turns, or anything, then it's linear. Okay, the second type that we will spend in second semester a lot of time dealing with is called a parabolic function. And these graphs tend to look U-shaped. Sometimes they're upside down, sometimes they're right side up. Okay, but they're U-shaped graphs with arrows at the end. Okay. The third type that we will have to make sure you recognize is the absolute value graphs. And these are the ones you will do a lot of in Algebra 2, but you have to be able to recognize them in Algebra 1. Right? And the easy way to remember those is these are your V-shaped graphs. They literally look like the shape V. So you have a U-shaped and a V-shaped. So you got to make sure you know the difference between the two. Right? And again, it can go upside down or right side up, but it's V-shaped. It has an actual point to it, whereas the parabolic ones do not. Okay? And the fourth one, which we'll see second semester, are known as exponential functions. And these are your curves. They start pretty slow moving and slightly increase, and then all of a sudden they take a nosedive up or down, right, at an exponential increase or an exponential decrease. So they're a curve, right? So those are the 4 function types, and we'll take a look at some pictures in class and see if you can actually name them, but you do have to know them on quizzes and tests for this class, just by picture and even just knowing the 4 names. All right, so now let's go to example 5, where you have to take a picture of a graph and that's already drawn and identify some of the pieces that it's looking for. All right, so again, I'll do a couple of these with you, and then I will leave the rest of them for you to play around with and try on your own. So let's try number 1 together. Remember, what's sitting in those parentheses represents the letter X. So they're asking you, if the X value is 4 on this graph, what is f of 4? In other words, what is the output or the range or the Y value? However you want to look at it, they're all synonyms to each other. Right? So you're trying to figure out the Y value that corresponds to X equals 4. So on your X axis, go over to positive 4 and go down to the line and put a dot where that graph is. All right, you know the X value is 4, so now use your Y axis and tell me what the Y value of that dot is. And you should be able to tell me that it's negative 1. All right, so f of 4 is negative 1. In other words, X value is 4, Y value is negative 1. All right, so try your hand at 2 and 3. All right, then go down to number 4 with me. Remember, f of x is really the same thing as the letter y. So they're asking you, find out what x is when y equals 3. So you do the same thing. You go to your graph, and this time you use the y-axis, and you go to positive 3, and you'll have to go over to the line and put a dot, and you're going to figure out what x value has that y value of 3. Okay, and you've come straight down to the x value right here. Right, you'll notice that it's negative 4. Right, so x is negative 4 when y is 3. Okay? And then I want you to try number 5 and see if you can figure out what x is in that one. Okay, so those will be ones that you do on your own. All right, for number 6, right, I'll show you one of these and then I'll let you do the other 4, because once you get the hang of the first one, the rest of them are pretty easy. Every time you have function notation written this way, you can write an ordered pair, and once you have an ordered pair, you can graph it on your grid. Right? Just remember that whatever numbers in parentheses represent your x, whatever's on the other side of the equal sign represents your y. Once you have an x number and a y number, you've got an ordered pair. So for number 1, this is the ordered pair -5, 2. And then you would come over to the graph and you would graph -5, +2, which is right there. And you do not want to connect these dots because these are 5 separate points on the graph. It does not say to connect them, you're just plotting the points. Right? So you try 2, 3, 4, and 5, and let's see if you can place the other 4 dots appropriately in the grid based on what I just told you. Okay? And then example 7, which is the last example of what we'll cover. Again, I will do a couple of these with you, and then you will be responsible for doing the other 2. All right, it's asking you to evaluate the following given the functions. Notice there's 2 different functions. One says g of x and one says h of x. Pay attention to your problems because they're going to tell you which one to use. So for letter A, it wants us to find x if g of x equals 9. G of x is the same thing as the letter y. Okay, but go to the g of x function right here, okay, and that's the one you're going to use. So we're going to stick in the g of x spot the number 9, and that equals 4x minus 7. And now we have to solve it based on our equation skills. So we have to add 7. You've got 16 equals 4x. Divide by 4. And you're going to find out that the x value is 4. Right? So when g of x is 9, then the value of x has to be 4. Right? If you come over and take a look at letter C, okay, then you're going to notice that you're using the h of x equation. So you go and you use the one that says h of x, and in the h of x spot you put the letter 0. So it's going to say 0 equals 1/4 x plus 3. Okay, and to solve this we would subtract 3. Okay, this is using your equation skills from unit 2 that we just got finished doing. You have -3 equals 1/4 x. To get rid of the fraction, multiply everybody by 4. On both sides. It cancels off your fraction, and now you're going to have -12 equals x. Right? So for letter C, the x value is -12. Right? But the y value that they gave us was 0. So you had to plug it into the right one and use it the right way. So you try letters B and D and all the other examples that I did not do through these notes, and we will see what kind of questions you come to class with, and we'll pick up from there and practice more with it.